Hello guys, today I'm gonna explain the fourth dimension. Four-dimensional space is the mathematical extension of the concept of three-dimensional space. Three-dimensional space is the simplest possible abstraction of the observation that one needs only three numbers, called dimensions. To describe the sizes or locations of objects in the everyday world. There is a fourth dimension, time. We move through that just inevitably as we move through space. And via the rules of Einstein's relativity, our motion through space and time are inextricable from one another. According to this model, there are only three dimensions of linear direction, variations of upwards, height, length, and width. But even with all the practicality of Euclid's model, the concept cannot be mathematically proven, opening the doorway to another fourth direction. Likewise, we can describe a point in four-dimensional space with four numbers. It is x, y, z, and w, where the purple w-axis is at a right angle to the other regions. In other words, we can visualize four dimensions by squishing it down to three, plotting four dimensions in the x, y, z, w coordinate system. The idea of adding a fourth dimension appears in Jean Leron d'Alembert's Dimensions, published in 1754. But the mathematics of more than three dimensions only emerged in the 19th century. The general concept of Euclidean space with any number of dimensions was fully developed by the Swiss mathematician Ludwig Schläfli before 1853. Schläfli's work received little attention during his lifetime and was published only posthumously in 1901. But meanwhile, the fourth Euclidean dimension was rediscovered by others in 1880. Charles Howard Hinton popularized it in an essay, "What is the fourth dimension?" in which he explained the concept of fourth-dimensional cube. With a step-by-step generalization of the properties of lines, squares, and cubes, the simplest form of Hinton's method is to draw two ordinary 3D cubes into the space, one encompassing the other separated by an unseen distance, and then draw lines between their equivalent vertices. This can be seen in the accompanying animation whenever it shows a smaller inner cube inside the larger outer cube. The 8 lines connecting the vertices of the two cubes in this case represent a single direction in the unseen fourth dimension. An arithmetic of four spatial dimensions called quaternions was defined by William Rowan Hamilton in 1853. Dissociate algebra was the source of the science of vector analysis in three dimensions as recounted by Michael J. Crow in A History of Vector Analysis. Soon after, tessarions and quaternions were introduced as other four-dimensional algebras over R. In 1878, William Kingdon Clifford introduced what is now termed geometric algebra, unifying Hamilton's quaternions with Hermann Grassmann's algebra and revealing the geometric nature of these systems, especially in four dimensions. The operations of geometric algebra have the effect of mirroring, rotating, translating, and mapping the geometric objects that are being modeled to new positions. In 1886, Victor Schlegel described his method of visualizing four-dimensional objects with Schlegel diagrams. And that's how the fourth dimension exists. Thank you.